So this video will cover the review for exam 3 of Math 1314 2015 fall semester. So what I want you guys to do as I'm writing the problems, please try to work them out yourselves, okay? We have the first problem here, graph the exponential function 2 to the power negative x, and we also have 2 to the power x plus 1. Now, what I'm going to do here first is I'm going to graph the parent function. So the parent function, actually, I'm going to graph that in black. And so the parent function is 2 to the power x. Now, I want you guys to realize that here I'm going to have a reflection across, since all the x's will be negative, or multiplied by 1, if one x is here, then it will be here. So that reflection will be across the y-axis. While you're studying, I want you to also study what happens when you reflect across the x-axis. Because you know that I'm not going to ask you the exact same questions, right? You know that. You should know that by now. Now, the other one that I'm going to graph has a vertical shift of 1 unit up. So you need to also study what happens when you do a horizontal shift, or what if the vertical shift was down, okay? And you need to look at your notes. So, and I know I took my time going over those. So going back to the parent function looks like this. It has the y-intercept at 0, 1. 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8. And then here, I don't need to be too specific, but as long as I don't touch the x-axis, I will be okay. Now, on your exam, maybe I will not use 2 to the power x. Maybe I will use 3 to the power x, or 4 to the power x, okay? So please consider that. But any exponential function that I choose is going to have the same y-intercept, and it's also going to have the same horizontal asymptote, at least for the parent function. So I'm going to go ahead and do that for both. Before I graph the transformations, I'm going to do that, so please do that, please. Graph both. All right, so we have that. And now we're going to graph the transformation. So the one that has 2 to the power negative x, I'm going to graph that in blue. And so we already established as a reflection across the y-axis. So all the x values are going to get multiplied by -1. So the y-intercept is the same. However, this point here is going to be here now. And the point that used to be 2, 4, now it's going to be at -2, 4. So it's going to be here. Same thing with the point that used to be 3, 8. Now it's going to be at -3, 8. What happens to the horizontal asymptote? Will that change? No, it will not. So then the points that go over here, you know, you don't have to be too specific. As long as you do not touch the x-axis, you'll be fine. Okay, now if you look down here. All right, going back to the test, there are some questions, and I decided that I'm going to leave the exam very similar, but like I already explained, the transformations might be different, okay? So don't just study this practice exam, because you know that I will not give you the exact same problem. I cannot stress that enough. So let's go ahead and answer the questions here. What is the domain for all exponentials? All real numbers, from -infinity to positive infinity. What is the range for this particular function? It goes from 0, without including 0, to infinity. You need to know that. Do we have an x-intercept? No, it's not even touching the x-axis. Do we have a y-intercept? Yes, it's at 0, 1. Do we have a horizontal asymptote? Yes, it's the line y equals 0. Now let's go ahead and graph the other one. We already established there's a vertical shift, 1 unit up. So we're going to move every single point 1 unit up. But what else moves with that? The horizontal asymptote, right? So instead of being this line at y equals 0, it's going to be the line here at y equals 1. So your graph is not going to touch the x-axis, but it's also not even going to touch the horizontal line y equals 1. So it will look like something like that. Now, let's go ahead and answer the questions. What is the domain? The domain is the same thing. What is the range? Now, the smallest y value is going to get closer to 1, so it will be, without including 1, so it will be parentheses 1 to infinity. The x-intercept, do we have an x-intercept? No. However, if that shifting had been down, then perhaps you might have an x-intercept. Okay? I'm just giving you a warning. So instead of going up, it had been something like that, then yes, we will have an x-intercept. How would you find the x-coordinate? Without using your calculator. Plug in a 0 for what? For the y, exactly. So you guys should know that. To find the x-intercept, the y needs to be 0. So this one doesn't have, y-intercept, we do have one, and actually it changed from the parent function. Now it's actually at 0, 2. What happened to the horizontal asymptote? F1, so the equation is y equals 1. All right, so let's go to the next page. Now evaluate the following expression. What I'm going to do here, and you need to show me because I am very aware that you can find this on the calculator, right? So if you want to get the points, you need to show me how you found the answer. Because if you notice, on the instructions, it actually says without a calculator. So please be aware of that. If you just tell me the number, I'm not going to give you any credit for it. So what I want to do here is use some of those properties that we went over. And 1 over 16 could be rewritten as base 2 like this. 1 over 2 to the 4th power. However, that's not enough. What I need to do is make that 2 to the 4th power be 2 to the power negative 4. And once I do that, I can apply that rule and the answer will be negative 4. The next problem, base 64. So that one might be a little bit tricky, but you could do the following. You can rewrite number 8 by using the square root of 64, because the square root of 64 is 8. So I will say the square root of 64 instead of the number 8. Now, from here, I'm going to turn that square root into an exponent. So that will be 64 to the power 1/2. And then I could apply that rule that says if the argument and the base match, then they cancel out, and the answer becomes the exponent. So that will be 1/2. Do you need to show me all those steps? Yes, you do. If you don't, you will not get the credit. Here, very simple. You have number 8 raised to this power, but you notice that it's log 8. That cancels out, the answer is 19. Here you could just do that cancellation. I'll be okay with that. The next one, what is the log of 1 of any base?
0.
0. You don't need to show me any work for that. And if you forget, type it on your calculator, because I'm telling you, you do not need to show me work for that. Yes.
So log base something 1 is always 0?
Yes. Because almost anything raised to the 0 power is always 1. Okay, next graph. That's a logarithmic graph. Now, let's graph the parent function first. On the test, you do not need to graph the parent function. I'm just graphing it so that you get an idea of how I'm doing those transformations. Okay, and also to kind of refresh your mind. So what I'm going to graph, it is log base 2 of x. And so this graph looks like this. Instead of having a y-intercept, it has an x-intercept at the point 1, 0. And then, actually, if we were to look at the first one that I graphed, this one here in black, and I just, it is the inverse of that, of 2 to the x, so I could just interchange the x and y coordinates. So I'm going to have the point for the log of x base 2, I will have the point 4 comma 2, and also 8 comma 3. Okay, so that is the parent function. Let's also graph that. It does have a vertical asymptote, and it is the line x equals 0. Now, if you notice, the graph that you have to graph, it is a horizontal shift. And it has a -3 inside the parentheses. That's how I know it's a horizontal shift. So it's going to move left or right? To the right. So this point right here is actually going to become 1, 2, 3. So it will become 4 comma 0. The point that we had here at 4 comma 2 now is going to be 7 comma 2. And then this point we can't even graph it. But another thing that will be shifted 3 units to the right is going to be the vertical asymptote. So now instead of being this line here, for our line, it will be the line, for our new graph, it will be this vertical line, x equals 3. Now please, while you're studying, looking at your notes, look at what happens if that shift was actually to the right side. Or what if I decide to throw there a reflection across the x-axis or a reflection across the y-axis? Because you know I could do that, right? You could also, it will be a good idea if you just like look at your notes, look at your homework. So what I would suggest you do is that you look at those tables of the transformations, okay? So what is the domain? Oh, well, let's trace the graph. So it's that one in blue. What is the domain of that new graph? Now, you can see here that it's getting closer to 3 without touching 3. So it will be from 3 to 0. Another way to find the domain is you take what's inside the parentheses and you can create an inequality that looks like this. That must be greater than 0, so x must be greater than 3. Now, if you want to give me the answer for domain and range in interval or set notation, that's fine with me, as long as you get it right. What is the range of this function? It is all real numbers. And if you notice, when we graphed the exponential ones, the domain of an exponential is all real numbers. So it makes sense that the range of a logarithmic is all real numbers because they're inverses of each other. Yes?
Isn't 3 to infinity?
Oh, yes, it is 3 to infinity. Thank you, Jonathan. So 3 to infinity, right? We have an arrow. X-intercept. Now we do have an x-intercept is this point right here, and that will be 4 comma 0. Y-intercept. Are we ever going to touch the y-axis? No. So we could just put NA. However, if the shifting had been done on the left side, then perhaps the graph will have a y-intercept. I'm just warning you. What is the vertical asymptote of the transformation? Is this line right here? X equals 3. Okay, for the next problem, it says to expand the following logarithms. And if you notice, the first one, the second one is not that difficult, but the first one, it has a lot of things there. So expect to have something like that on the test. So please review your properties, the product rule, the quotient rule, and of course the power rule. So I'm going to use all of them at once. Well, I'll do it by steps. So remember what I told you. Every single term or factor that is on the numerator is going to have a positive sign, all right? Because you're expanding the log of a product into the sum of logs. So here I'm going to have the ln of 10 plus the ln of x squared plus the ln of the cube root of 1 minus x, but what I want to do is use fraction as the exponent instead of the cube root. Now on the bottom, remember I told you, stuff that we have here needs to have a negative sign in front of it, right? So it will be minus the ln of 7 minus the ln of x squared, x plus 1, and then square. Now from there, we're going to apply the power rule on certain things. So the final answer will be ln of 10 plus 2 ln of x plus 1/3 ln of 1 minus x minus ln of 7 minus 2 ln of x plus 1. Yes? Yes.
So all the exponents just become coefficients?
Yes, that it will be the power rule. All the exponents become coefficients. Okay, the next one is pretty simple, but you actually have to simplify a little bit. Here we have the log of a quotient, so that will become the difference of two logs. So this will be the log of base 4 of 64 minus the log of x base 4. Now what I need to do here is rewrite 64 with a base 4. So we know that 4 squared is 16 and 4 cubed is 64. So that's what I'm going to do. 4 cubed instead of 64. So then I can apply that property because that says if the argument and the base are equal, then you could cancel that out and the answer becomes the exponent. So from here, it becomes very simple. It will be 3 minus the log of x base 4. I think you guys are going to do good on this test. I'm trying to be positive. Because my last year's dual credit, didn't they do good on that test, on the second exam?
Yeah, we did.
Well,
And that one. And that one.
And this one, yes. So, I mean, you know, if you have a friend who is not here, make sure you tell them to watch the review video. Okay, next one. Now we're going to condense. So we're going to go from several logs to one log. And I cannot stress this enough. Your answer, please write this down. Your answer must have log or ln written only once, because it says condense. So if you are doing your work and then you find yourself with log more than once, then it's wrong. And then you're not going to get the credit. And you're going to make me mad. All right, so first of all, I'm going to use the power rule in reverse. So now the coefficient becomes the exponent. I mean, you don't need to draw the circles and the arrows. Well, if you don't show me your steps and you get it wrong, then it will be very difficult for me to give you partial credit. If you get it right, that's fine. So this will be ln of x cubed plus ln of y to the 5th minus ln of z to the power 6. Now, if we condense, because we could only have ln once, right? Only once. This will be ln of x cubed and y to the 5th in the numerator. Why are they in the numerator?
Because there's a positive.
Positive, right? They both have positive. And then for z to the power 6, that will be on the bottom. Why? Because it's negative, right? Okay. Now let's move on to the next one. So here we have 1/2. What I'm going to do, I'm going to go ahead and distribute that 1/2 first. So that coefficient, 1/2 outside the parentheses, actually becomes the coefficient of both log of x base 5 and log of y base 5. So we'll have 1/2 log base 5 of x plus 1/2 log. Well, actually, that was an easier way to do it. Let me try something different. You guys like easy things, right?
That's the spirit.
Okay, so this 1/2, I'm going to bring it here. And so it's going to be that. Actually, no, let's not do that yet. Don't start complaining. Let's go ahead and condense this part first. So it will be 1/2 times the log of what? The sum of a log condenses into the log of a product. So the log base 5 of xy. Minus 2 log base 5. Could I condense this?
No.
No, right? That rule doesn't apply to it. So now what I will do is use power rule in reverse. And I will have log base 5 of xy to the power 1/2. And then minus log base 5 of x plus 1 squared. Now from here, I'm going to condense again because I could only have the word log written how many times?
Once.
Only once. And I promise you, if you have that word more than once, you will not get any partial credit. Okay, so log of xy, that will be on top because that is positive. And instead of 1/2, to use that exponent, I'm going to use the square root. And now the x plus 1 squared will go down here. And then maybe I could use either parentheses or brackets, whatever you prefer.
So you write down log of base of like.
Oh, base 5, yes. Please do not forget that because you do not want to lose those points. Because if I leave it blank, what base would that be?
10.
Base 10. Very nice. For my next question, you have to solve some equations here. I'd strongly suggest that you review the ones from your homework and specifically the ones from your notes. Review all the steps. I know I'm a good teacher. If you want to be a good student, you will review your notes. Okay? I have 3 here, but I'm not saying that the ones on the exam will be exactly the same. All right? Now, the first one implies using that rule where you use the one-to-one property of exponentials. So 125 could be rewritten in base 5, right? And that will be 125, that is 5 raised to what power? 3. Okay, now from here we know that 5 is equal to 5, so we assume that the exponents are also equal. So 3x minus 1 is equal to 3, and then from here you could solve it. It's like a regular linear equation. That would be 3x is equal to 3. This negative 1, move it across, becomes plus 1. And from here, we have 3x is equal to 4. What is the x doing to the, what's the 3 doing to the x? Multiplying, so we need to divide. And you could just leave your answer like that as a fraction. Now, one thing that I would suggest you do is that you go over those examples that we did when you have things like 2 cubed, and then you have an exponent like that. Or 2 to the 4th, and then you have, 2x minus 3. What would you guys do there?
Multiply the exponents.
So you multiply the exponents, right? But when you do that, do not forget to distribute, all right? Because if you don't do that, then remember, you must distribute there. So you end up with an equation that looks like this. 3x plus 3 is equal to 8x minus 12. And I've seen this happening a lot. Students are very good about multiplying the first one, but then they forget to multiply by the second. Okay, so please be aware of that. So you don't have any surprises. I mean, you will have surprises, but hopefully you'll be able to work them out. Next problem, what do you guys think we should do with the left side? What? What? Make it 0. Condense. Thank you, Sean. So we condense. We have the difference of 2 logs. So we will condense it as the log of a quotient. So the log base 2 of x plus 2 divided by x minus 5 is equal to 3. Write that. Now from there, what should we do? Change to, start with an e, exponential. So that will be 2 to the power 3 is equal to x plus 2 over x minus 5. 2 to the power 3 is equal to 8. Here we have x plus 2 over x minus 5. So now what I need to do is take this x plus 5 that is dividing on the right side and move it to the left side, and it will be multiplying. But please make sure you multiply both x and negative 5 by 8. And here I have x plus 2. Here you must distribute the 8, so 8 times x, 8 times negative 5. So that will be 8x minus 40 is equal to x plus 2. I'm going to move all my x's to the left side, so 8x minus x is equal to 2 plus 40. So here we'll have 7x is equal to 42. And then 7 is multiplying to the x, so we have to divide by 7, so we'll have 42 divided by 7, so x is equal to 6. Thank you. Yes?
So when we're putting it into exponential form, is the base, okay, so equals 3, right? The solution, is that always going to be the exponent for the base?
Correct, yes. So the base of the logarithm is always the base for the exponential, and the solution of the logarithm is the exponent of exponential, yes. Okay, next problem. I'm going to start by, I'm going to convert to logarithmic, but before I do that, I need to take care of this negative 7. It is subtracting on the left, so once I move it across, what is it going to do? Add. So we have e to the power 4x minus 5 is equal to 11,243 plus 7. E to the power 4x minus 5 is equal to 11,250. From here, I'm going to either take the natural log on both sides or convert it straight to logarithmic form. So that will be natural log base e, that is implied, we don't need to write it, but if you need to, that's fine, of 11,250 is equal to 4x minus 5. Now from here, before you even calculate what is the natural log of 11,250, we are going to have to take care of this negative 5. It is subtracting on the right. You move it to the left, it's going to be adding. So we'll have ln of 11,250 plus 5. That number is not including with the argument of the natural log, okay? That is separated from it. So what I'm saying is, like, don't add 11,250 plus 5 and put it inside here.
Miss Evans,
Yes.
is it okay if we write it on the other side, like 5 plus the natural log?
Yes, that's okay. And so I also have here 4x, right? So to finish this equation, it will be x is equal to the ln of 11,250. You close your parentheses, and you know that your calculator opens and closes automatically, right? I mean, yes, I think it does both. And then plus 5 and then you divide by 4. Okay, so be careful with that. All right, but problem number 7, the half-life of aspirin in your bloodstream is 12 hours. So remember, we were talking about half-life today for my 7th period.
Oh, we're doing that in calculus.
Oh, how long will it take for the aspirin to decay to 70%? All right. So first of all, I'm not really giving you any like part A, part B. So you're gonna have to figure that out. All right, because you're not babies. So I will really suggest that you do your homework from section 3.5, okay? If you can do that without looking at the examples, I promise you that you'll be able to solve the 2 problems that I select, okay? So first of all, I need to find K. And we're talking about the aspirin in your bloodstream is going to be decaying, right? So we can anticipate that K is going to be negative. After we find that, we're going to have to answer the question, and the question is, how long will it take for the aspirin to decay to 70%? So the final amount is going to be 70% of the original, and we're going to have to find what? T. Yes, T, because the question is how long. So it's a 2-part problem. Yes.
So, okay, 12 hours is the half-life, right? So would it be at 50% its original dosage after 12 hours?
Yes, correct. So if you're taking an aspirin that is like 10 milligrams, after 12 hours, you will still have 50 milligrams in your body.
Okay, so...
Or what was my original? 10. Okay, 5.
Okay, so
5.
Can we get...
No, don't try to take shortcuts here. No, don't. Because you will not get full credit. All right, anyways, so we start with this model, which is final amount is equal to the initial amount times e to the power kt. We're finding k. Now, all we have is the fact that the half-life is 12 hours. So what we know is that the final amount will be 0.5 of the original. The original is just the original. We don't even know what it was. And we know that it took how long to get to half of the original? 12 hours. And we did problems like this today, right?
Yeah.
You should be able to solve them. So I'm just going to solve it quickly. So 0.5 a sub 0 divided by a sub 0 is equal to e to the power 12k. From here, a sub 0 divided by a sub 0 is 1, so we may say it cancels. We have 0.5 is equal to e to the power 12k. What I can do here is convert to a logarithmic equation, so it will be the ln of 0.5 is equal to 12k. If you don't feel comfortable doing that, you could also do the following. You take the natural log on both sides, and then you apply that rule that says that the base and the argument match, so it cancels, right? And the exponent becomes a linear quantity. Now, from here, do not calculate the natural log of 0.5 yet. It will just be ln of 0.5. What is the 12 doing to the k? Multiply, so we're going to divide. Now, from here, you will get an approximation. Can someone with a calculator do that for me, please? Oh.
I think it needs more cream. Yeah.
Okay.
More, not all.
Come on, not everyone at once. Okay, Ruben.
Negative 0.0577.
0.57.
Can you run into the fourth? Or
I don't know. What do you have?
762. Another 7.
762. So let's just truncate it there.
So it would be
So, yeah, you would do 8 instead of 6. Are we always going to round like 4?
I like 4. So what would we round it to?
7, 8.
7, 8.
7, 8. Okay. All right, so that's fine. Now we're going to take the information from here, and now we're going to use it here. So now our model is like this. The final amount will equal to the initial amount times e to the power, instead of k, now we can substitute with this number, negative 0.0578 times t. And remember, now we're finding t, the time it takes for the aspirin to decay to 70% of the original dose. Now last year, our tutor, he actually taught my students something wrong, and he used to tell them to subtract that from 100%. Don't do that, okay? The problem says to decay to 70% of the original dose. It doesn't say to lose 70% or to, I don't know how to word it, but just trust me, you will answer it this way. Now the original amount is 0.7. I'm sorry, the final amount is 0.7 of the original. We have the original here. And we're going to solve it the same way that we did the first one. So we will end up dividing by a sub 0. So we'll have something like 0.7 is equal to e to the power negative 0.0578 times t. Remember, we're solving for t. So here we can take the natural log of 0.7, and that will equal negative 0.0578 times t. And finally, to solve for t, it will be the natural log of 0.7 divided by negative 0.0578. And then we will get an approximation. Does the question state like to round or anything like that? No? Okay. Just keep in mind that if the problem involves like people, animals, days, you might want to round to the nearest integer. Okay? So here we're talking about hours. Maybe 1 decimal will be okay. Can someone give me the answer for that? 6.6. And we were talking about hours, right? And I mean, I'm not as strict as one of our chemistry teachers used to be with the units, but with your final answer, it needs to make sense, okay? Don't say months or years. All right, last problem. In 2000, the population of Israel was approximately 6.04 million, and by 2050, it is projected to grow to 10 million. So right here we have in 2000, it was that. We could consider that the original amount. Moreover, we could consider the year 2000, t equals 0. And at that time, the population, which I will call a sub 0, was equal to 6.04. Now we have another statement here that it is projected that by 2050 will grow to 10 million. So the year 2050 will equal to t equals 50. And the final amount at that time, it is projected to be 10 million. Now the question here is, use the exponential growth model, that one, in which t is the number of years after 2000. I already explained that to you, to find the exponential growth function that models the data. So in this case, this will just be a one-part problem. I don't want to like crush your dreams, but I don't think I will give you a one-part problem. It's probably going to be a two-part problem. Two problems that require two parts. One thing I want you to also consider are to study on your notes are problems involving compound interest, as well as continuous compounding. So please review those on your notes. And I will also like for you to practice at least, well, on your homework, you should have a couple of Newton's law of cooling. Let me specify which one, because I don't want you to be looking forever. All right, so just to finish this problem, we use this as our final amount. So that will be 10. The initial amount would be 6.04. We have E. We are looking for K, and T is equal to what? 50, right? So here, we solved it the same way that we've been solving all these problems. The 6.04 is multiplying E to the power K times 50, so we divide. And from here, you could either take the natural log on both sides, or you could just convert it to logarithmic, so it will look like this. And then finally, the K, the 50 multiplies the K, so we move that across, and it will be doing the inverse operation, so it will be divide. So can someone please, whose name is not Ruben or Brisa, give me the answer? Yvette, could you please turn on the light?
That's weird.
It's because there's another one in us. Yes, Gabriel? Well, we're talking about population growth, right? So is K going to be positive or negative? Positive. So if you get a negative answer for K, then you might know there's something wrong. Okay? So go ahead, Gabriel.
0.0100.
And then will there be another decimal?
84.
84. So in this case, we might want to take more than 4 decimals. Okay? So we could get a more meaningful answer. Now, the question to this problem was just find the model. So it will be the final amount to be found by using the initial amount, which we were given 6.04 times e to the power 0.010084 times t. And that will be the answer to that problem. Okay, if you could have one formula on this test, which one would you like to have?
The A equals like final A and then the initial A.
Like the one here?
Oh, will it be there like in the problem?
I don't know. I don't know what problems I'm going to use. Okay, so this will be the end of the video. Okay, one little correction. The answer here, instead of being 6.6, should be 6.2. So if you got that on your calculator, just don't worry about it.